In section 2.2.RA-3, the data over here to your right represent the per capita average disposable income after taxes, for 25 randomly selected cities in the recent year. We're going to complete part A and B. So we want to construct a frequency distribution with a first class having a lower class limit of 30,000 and a class width of 6,000. So if the lower class is 30,000, that means you need to start at 30,000. And so now the width is 6,000 according to the question here. So this is considered the width. So you're going from 30,000 to 36,000. So you're adding 6,000 here. And then from 36,000 to 42,000, again, you're adding 6,000. So this is considered the width. Okay? So what that means is that if this is the lower class limit, because that's what it's saying, lower class limit, I'm just going to put lower in here, then this is the upper class limit. Okay, and the upper class limit in this particular example ends at 35,999. Now, I also want you to notice that we know that we have our, it's 6,000 between our width, which also means that over to our right, this also has a width of 6,000. So that means you're going to have 6,000 here as well. So now what we want to do is we want to be able to count up all the frequencies that are in between 30,000 and 35,999. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So we get 13 that's in between this class. Okay, then we want to figure out how many are there between 36,000 and 41,999. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So there we have 11. Okay, are there any numbers between 42,000 and 47,999? Well, it doesn't look like there is. So we have 0. And then let's take a look at the values that are between 48,000 and 53,999. So there we have 1, and so therefore there's 1. Okay? So the classes are represented by intervals of numbers. The lower class limit, again, is the smallest value within the class. The class width is a difference between consecutive lower classes limits and is the same for all classes. And then you start by filling in the class limits, and then the intervals for the different classes should not overlap. Okay? Now, for part B, we want to construct a relative frequency distribution with the first class having a lower class limit of 30,000 and a class width of 6,000. So again, we're going to have the same class size. Okay, but now we want to be able to figure out what is the relative frequency distribution. So we need to find out the sum of the frequencies. So when we add these all together, 13 plus 11 plus 0 plus 1, we get the sum of 25. Okay, and then to find the relative frequency for 13, we take 13 divided by 25, And what that does is that gives us an answer of 0.52. So there's your relative frequency. And we take the number 11 and then divide it by 25 to get a relative frequency of 0.44. Then we take the value of 0 divided by 25, which gives us 0, so therefore it's 0. And then the last one, we take 1, divide that by 25 and get 0.04. And therefore there is our relative frequency.